Okay, you have enough.
plenty of space.
Oh, okay, okay. So it's recorded. No, it's recorded. Okay. Everything is good. Everything is good, right?
Yeah.
Is that comfortable?
Yes.
Excellent. Oh, yeah.
We have a lot going on next, like all the potential spring break. I'll just mention this, and there's some new stuff too. So excited to have it at lab. What we can say is beyond if I run the talk the next question, and it's about it's not really also before Pi Day. Senior Pi Fest in the Department of Ethics. On April 8th, Dr. Cummings is coming to give a talk. We have Spatial on the 5th, and integrating these stuff. And another thing is, people who work in the last couple of meetings, we have a teacher district around. Everyone's super.
All right.
So, this is my presentation. I'm doing a presentation into prevention. I'll hopefully try to make sense. If not,
I hope all of you have taken Calc 3 because it will make not a lot of sense if you haven't. So I wrote a question a year ago for the Math Club. It was a challenge question, and it was to find the hypervolume that is created when you rotate a ball, ball with the standard volume into the fourth dimension around a axis that is tangent to it. Or, well, that was the original question, and then I'm trying to generalize it to my problem. So it might look a little bit different using an R. So this, I don't think anyone has considered it, including myself. But I have a solid temp at it. And so this is a picture of the over-dimensional version where you rotate a disk into the third dimension to get a torus. And the way I did this is there's always a total of from generalized into higher dimensions. So that's the method that I used. So this setup is from using the where B is yes. B is how far from the axis the disk is, and A is going to be the set radius of the disk. So I am using cylindrical coordinates in this. So that would be taking polar coordinates and then adding the axis. And the polar coordinate, the 0 to 2 pi and b minus a b plus a is just describing basically the creation of a washer and the flat plane. And then this next to your bounds is describing how those washers stack up to form limits. So this works. I test this. It ends up yeah. So that's what it gives us, and that is in fact the equation of a torus. Given parameters of A. So the way I set up the four-dimensional version of this problem is I try to think about what all the cross-sectional volumes are. Cross-sectional volumes basically taking just a peek into the fourth dimension to see what that third dimensional version looks like. Similar to how we take a cross-sectional area of a 3D shape, it's just sliced into the second dimension. We're doing basically the same thing, except in the third dimension, and it's going to have more cross-sectional than a three-dimensional cross-sectional area. So that's like four. Two of them are going to be two balls, one flip, that's not hugely important, and then one course. I'm not sure what the last volume will look like, but the way I'm computing hypervolume is with there's other ways to do it. There's you can just do it. That takes one rotated. I got confused that, so I ended up this way. Which should be set up. So the way I thought about adding intervals get from the washer setup how we started earlier. The first two intervals on the outermost two intervals are setting a washer, and the Z is stacking those washers to make a donut. The way I'm thinking about to my triple intervals that's hypervolume that describes the hyperdonut is to basically stack that up inside of the interval. So we have one inside of the other. And this is one of the cross-sectional points where we have two spheres. This is the equation of just one of those spheres, or all. I only care about one. Rotating up the entire thing, but you can two examples because they're just so this is my attempt at the solution to find what the hypervolume is. The way I got this is just through rearranging the previous in terms of what W equals and using the substitution to the top left, and because those are just the substitutions for a perfect. Basically, the W isn't a DW. Yeah, it should have a DW right here, but it got crossed out. But so it the W isn't like a rotation axis, how D is a rotational axis, I guess you could say. The DW is going to be one. It's going to be another just general rotation axis that's an axis. That integral is actually not helpful. MATLAB and Wolfram Alpha both do not compute it doesn't exist. So what I think the issue is that the innermost variable is, or rather that whole quadruple isn't describing it's describing something else. Because the innermost variable is talking about basically how a ball could be rotated into the triple interval is for a torus. The inner one is kind of how I would say it takes sphere rotated into the fourth dimension, but the interval isn't for a ball. It's for a donut. So that's what I think went wrong. I'm not entirely positive. I'm going to make more attempts to see what happens, but as of now, I'm not sure exactly what went wrong. So yeah, the bounds are talking about a different object, probably not even an object that exists, not really one that you think about that. So the only way to fix that is to see what that's actually describing and see if I can change that to describe So I was looking at the outermost interval as rotating around the z-axis. The r to which is the next one. See how far away from the z-axis it should be, and then stacking it. The z-axis stacking it with the w-axis, or stacking that. What I should do instead, since we're talking about ball, orbit 40 axes. Okay. And that might work, it also might not. So mostly this is important because one, I'm showing you an example of how even despite that I didn't succeed, despite trying for over a year at this point to try and solve this problem, despite that I still have next steps and fail until I give up. And it's really important to not just give up, because giving up is the only 100% chance of failure you have. That's the only where you're going to fail sometimes. So it's also important because it's an interesting way of thinking about higher dimensions, and potentially, if I figure out how to generalize this method, that was talking about any higher dimensional shape beyond the 4th dimension, then that would allow, well, me and to be able to better describe and understand higher dimensional spaces, what those look like, what objects do in those spaces, and how that's what's so it's work, also it's fun. So thank you all for listening. This is a short thing. That's fine. Does anyone have questions about any? Yes. It took a while, but it still didn't really but there's no actual function that drives into yes, but one thing I was that's what I'm trying to figure out. The code. Oh, the code? It took me like 10 minutes. Because it was really just putting in the integral, like, solve this. I don't actually know if I have the code. The map. Oh, set up.
Wait, why did you get her email? You didn't put yours.
I don't know. I'll.
Well, like how? Yeah,
No,
but
it's my
like-
laptop.
Your laptop too?
Yes, my laptop.
I'll figure that out later. I can post it on this. It's not complicated. The worst part is girl, you know, so
I know you're aiming towards a hyper-torus, but instead of trying to rotate the sphere around an axis that you can't see, would it be easier to stack this sphere on an axis that you can't see? So instead of a hyper-torus, kind of like a hypercylinder?
Yes and no. What I'm currently doing is stacking the. What I'm currently doing, I think, is here. So these three are the torus, and what I'm essentially trying to do with this interval is to say how I'm stacking this shape to get to the fourth dimension. I don't know if it would be necessarily easier to do like a cylinder. It probably would be, but I'm not sure how I would go about it. At this moment, I have to think about it.
I mean, you think about this one for over a year. It'd be weird to take a right turn at that one.
Yeah. If I can figure out any shape of the fourth dimension, it might help. The goal is just to describe objects in the fourth dimension. This is just kind of the setting itself into a generalization, a general method of finding any object or any. If you want to see the map, I do have it. But it's long. I can show you the one for the just the triple integral for the torus to show you how bad this is. This is just talking about stuff, but here's the actual integration. Using LaTeX. Yeah. Yeah. So I have the math for the other one as well, except it's a lot more pages.
Yes, I have a question.
Yeah.
Is the conjecture, are you making the following conjecture? That definitely the volume of this four-dimensional object should be expressible in terms of elementary functions of mathematics. Is that part of the conjecture? Because we are saying that we made efforts for months and there was no elementary function or a combination of elementary functions that we obtained as a output of this integral. Let's for a moment assume that everything about this integral is correct. This actually gives us the measurement of the volume that we do. Okay? Because we know that there are very simple things in math and we cannot express them in terms of elementary functions. Why are we assuming that definitely this is not one of those cases, that the answer should be expressed in terms of elementary functions?
For one, because you can actually Google the volume of the hypertorus, and it will actually and it actually does pull up stuff. So, and they're expressed in just terms of pi, r, and other stuff. So I would assume, based off of the fact that there is stuff out there on the internet. So
if the Wikipedia says that that's something, but
yeah.
we saw that far out, that is the method of
I believe there is. Wikipedia is great. It's like one of the most accurate sites there is.
for other things.
See how long it would take.
Do
All of it was like all of the people was like 10 minutes. Maybe their jobs. Yeah.
Hmm. Oh,
Yes, and if we manage to define the formula, maybe by doing a little bit of reverse engineering, we be able to figure out what should be done with that one. So
Yeah.
to actually find, if we can find the actual formula, that.
I would assume so because you can find the formula for the volume of a hypersphere. If you can find the volume of a hypersphere, you can describe a torus or donut, a hyperdonut, by just talking about spheres, a lot of hyperspheres, kind of like in a circle. So based on that assumption, I would assume there is a volume. I can't find the website I found earlier last year that talked about it, but I would assume there is an actual solution to this problem. I would assume, but
Makes sense. Yeah, if you find it, the formula, I think that's worthy of considering. In the sense that one thing is to ignore that formula, I wanna find it without looking at it. But if there is such a formula, maybe that can give us some insight to what's going on with those intervals, how we should like manage this.
yes.
I also wanted to give this now because I also wanted to thank you so much for that slide about persistence. Right, it happens a lot, many of us after 2 hours that we give up. But the real problem may take 1 year, more than maybe years, right? It's just us is spending time on it figuring out. That's incredibly good advice in my life. Thank you so much for sharing.
This is specifically, you're doing a torus being rotated on a tangent to an axis tangent to.
That was the original question. This
This one's generalized, that's what your B is.
as long as the sphere is tangent or farther than the axis of rotation, it should hold. If not, I think some weird stuff happens.
Well, you
Doesn't work
probably
so
got
well.
double count.
Yeah.
They're not built in, like extra counting that area.
Yeah, you'd have to take that out. If it actually did work, it would work for any sphere that's tangent or farther away from the axis of rotation. I think I'm sure, but it doesn't have the right words in my document here. Yeah, so something like that. The
Distance.
the
Is
di-
it
it
distance
should-
from the center or distance from the closest point of the
distance
sphere?
of the center is going to be the B in my presentation. The B here is the distance to the center of this of the ball, and the A is going to be the radius. So the distance from this axis of rotation to the closest point is going to be B minus A. Hence this integral.
So I'm thinking you want to try doing it specifically tangent first, see if you can get a general or a nice formula for it, and then try to generalize that.
I don't know if that would be easier, because that would just mean that the B would equal A.
R squared
So-
minus R squared cosine squared.
Yeah, so every B I could just replace with A or vice versa. I'm not sure if that makes it all that easier or more solvable for that matter. In this case, I might try that if I or when I do more solutions or an attempt at another solution.
Also, while we're here, on topic of the on the we had last spring, I think I won the last year.
Yeah, good job.
You have very hard questions.
Okay, the first two were not that bad. There's the latter three that were a lot worse.
Can't wait to see what more progress you make.
Oh, yeah. Thank you. Thank you. Any other questions or comments or insight?
Give another ball for us.
I can write more.
You're able to get, so are you gonna try to do it for any dimension?
Yeah.
That seems like your goal.
I'll probably have to make some notation for n integrals or
That
something.
it exists.
Oh, it already exists? Cool. I don't have to make a new
There's
notation.
formulas for it.
Awesome. Yes, I can.
Give everybody a t-shirt.
That sounds great.
Like, have like, all those pictures. I mean, like, if they're cool,